Welcome to the Math 1 lesson summary video for the task Making My Point, a solidify understanding task. Zach and Sion were working on predicting the number of quilt blocks in this pattern. So as you can see, it's summarized for us in the table down here. So we have n equals 1, the first set of blocks, there's 7 blocks. Then at n equals 2, there's 13 blocks. N equals 3, there's 19 blocks. And so Zach and Sion both came up with different rules. So Zach said, all right, if I reverse this pattern, well, first of all, he noticed that it's adding 6 blocks each time. So he said, if I reverse that and I go from 7 down by 6, this pattern would have started with 1 block. And so he got the rule 6n plus 1, or y equals 6n plus 1. Sion, on the other hand, she started from the first block. When we start at n equals 1, we have to do this n minus 1 adjustment to our rule. So she got 6 times n minus 1 plus 7. I'm going to underline that so the 7 doesn't get cut off. So two different ways of writing the same rule, and they are equivalent because if I take Sion's rule, 6 times n minus 1 plus 7, and I distribute it, I get 6n minus 6 plus 7, which is the same as 6n plus 1. It's the same thing, there's just different ways of writing it. And so the purpose of this task is to introduce something called point-slope form of a linear function. So if we keep on going, we can see that this idea of the n minus 1 adjustment can also be applied at other values of n. So here's the table where it starts at n equals 3. So again, Zach is thinking of it as, well, let me work my way back to figure out how many blocks there would have been to start with. It's still adding 6 each time. Oh, sorry, this time it's adding 4 each time. So he's saying if it went down to 2, then this would be 9. If it went down to 1, then this would be 5, and at 0, once again, there would be 1 quilt block. So Zach writes the rule for n plus 1. Again, Sion says, well, I tried the n minus 1 adjustment before, so let me try an n minus 3 adjustment here. And so she got 4 times n minus 3 plus 13. So let's see if that is again equivalent. So if we use the distributive property, that becomes 4n minus 12 plus 13, which is 4n plus 1. So it's actually the same thing Zach got, it's just written in different format. So what we're going to notice is that the format that Zach is using every time is based off of the slope and what's called the y-intercept. So that's called slope-intercept form. And it requires you to work backwards to figure out what the y-intercept would be in some cases. Now, what the form that Sion is using is called point-slope form. And so now we want to compare the two. It can also work if I have a linear function. So what we notice in these problems is that they both have the same graph, and they base it off of different points, and they write different equations. So either way, the slope of this graph is 3 because we're going up 3 and over 1. So you'll notice that they both have a 3 in their equation. So Sion had this equation, and then Zach had this equation. And they both have a 3 in their equation. So what Zach says is, okay, well, I was basing mine off of the slope and this point, 1 comma 5, where Sion was basing hers off of the slope and this point, -1 comma -1. And so it turns out they're both correct. They both have valid representations of this line that's graphed. And we can see that they're equivalent representations of the same line if we look at a graph of each line in Desmos. So here's Sion's line in red, and there's Zach's in blue right on top of it. So they're equivalent because those lines are perfectly aligned. It's the same graph. And so we can see all the points from the table, -1, -1, that's on that graph. 0, 2 is on there, 1, 5 is on there, and then the last point from the table, 2, 8 is on there. So not only is it are they equivalent, but they both match the graph that we were given. So what we learned from this is it doesn't matter which point you use, whether like Zach used 1, 5 or Silent used -1, -1, as long as you follow a certain pattern, you can write a linear function rule in point slope form. So then Zach noticed my equation made me wonder if there was something special about the point 1, 5, since it seemed to appear into my equation, f of x equals 3 times x minus 1 plus 5, when I looked at the number pattern. Now I'm noticing something interesting. The same thing seems to happen with your equation, f of x equals 3 times x plus 1 minus 1, and the point -1, -1. So the pattern that Zach is noticing is that inside the parentheses is appearing the opposite of the x-coordinate. So we can see here the x-coordinate is 1, and then the opposite of 1 is -1 appearing here. Same thing over here, the x-coordinate is -1, and then the opposite of -1 is +1 appearing here. And the other part of it is that outside the parentheses is appearing the y-coordinate, not the opposite of the y-coordinate, but just the y-coordinate. So I have -1 here is the y-coordinate, and it's -1 outside the parentheses. I have 5 here is the y-coordinate, and it's +5 up there. So that's interesting. So in general, what would the pattern look like if the point was h comma k and the slope of the line was m? Well, we have y equals m, the slope always been outside, and so that would have been important to note in problem 4 as well. Slope is in front of the parentheses. So we have y equals m times x. The opposite of h would be -h or -h, and then the y-coordinate goes outside the parentheses, so plus k. And that's a way of writing point slope form, which we'll talk more about in the next lesson and next video, what that looks like officially. But to apply it, if I know a line has a slope of 4 and goes through the point 2, -1, well then I could write the line y equals 4 times x minus 2, because the opposite of 2 is -2, and then -1. And to check to verify that that's correct, I could graph it in Desmos to make sure that it does in fact go through the point 2, -1. Or I could substitute -1 in for y and 2 in for x and make sure I get a true equation. If you need help specifically with the Ready, Set, Go problems, then please check out the Ready, Set, Go student support site in Canvas.